Welcome, Roboteers. This is our live event number 3 about the robot project. I am Jason Shanks from the MOOC teaching team, and today I have with us a face and a voice I'm sure you will recognize if you've been active on the discussion forums, Jack Slater.
How you going, guys?
All right. He's here to share with you some pointers on the robot project. He's brought in his own project he actually built during his time in the course. And we have a few questions that have come up in the last couple of days we'll try to address for you. But first, some housekeeping. We have a couple of questions around the actual when it's due and the peer assessment. So let me try to answer a couple of those for you first. Submissions will be open on the 6th of April, and there'll be a 2-week peer assessment period from the 6th until April 20th. So we encourage you to submit those as soon as possible. After the 6th, you will be allocated 5 people to assess your project, and we need at least 3 of those to get back on their peer assessment to finalize that. The other part question was, do marks go towards the certificate? The answer to that would be no, because the actual project is an optional component of the course. So it won't count towards your certificate. However, those that do complete the project, you will be acknowledged with a letter of achievement. And there will be a lot more details about this and all the exact particulars to the peer assessment coming out in an announcement soon. So without further ado, over to Jack to tell you about the project.
Oh, just on the peer assessment, when you submit, there's only one chance to submit. So you're going to be submitting a link to your YouTube video. Make 100% sure that that link works, because if it doesn't, people are going to come across, try the link, and then a broken link or something like that. They can't mark your thing, and you're going to end up with, you know, no marks or whatnot. If it does happen, if something stuffs up and, you know, it didn't work, just email us. We'll go through and we may even end up marking it ourselves. So don't panic. Just, you know, take caution when you're doing it. Just make 100% sure that your link works. And that was it with that one.
Good point,
yeah. Yep. So I'm going to move on to the robot that I built. I whipped this up last night. Now, I had quite a bit of trouble setting up the MATLABs that would talk to the robot. I'm pretty sure I had most problems, most things that go wrong, went wrong when I did it. So if you have any questions, throw them on the forum. I should be able to answer them. Basically, the way I did it, I don't know if this is a recommended way, but this way works. You guys might have better ways, and if you do, throw it up there, you know, and other people might do that way. But the way I did it was I went to the MathWorks website. I downloaded the NXT Toolbox, the MATLAB NXT Toolbox. Inside it, it's got a motor controller, a whole bunch of stuff for using the motor controller. Now, what you need to do first off is get a file called motorcontroller22.rxe, and you want to put that on the brick. Now, to do that, the brick, well, your computer using needs to recognize the NXT brick. And then so what you want to do is download a driver. The one you want to use is the Phantom driver. It's relatively easy to get. So once you get that, install it, and you should look in Device Manager, Lego, and there should be NXT brick in there. Once you have that, Google a program called Next Explorer. It's spelt capital N, E, capital X, capital T, capital E, XPLORER. I don't know why they named it like that. It's a bit weird, but just, yeah, Google that, download it. Now, this program allows you to load the motor controller file onto the NXT brick, and you have to have it there. Otherwise, MATLAB can't send motor controller commands to the brick. Once you've done that, that's all well and good. Now, this is what I did. I went straight onto MATLAB and went, whoa, yeah, I've done it all. Sent a command to the NXT brick and it went, whoa, NXT brick not connected. It doesn't recognize it or something along those lines. After quite a bit of searching around, I found that you need to install the LIB USB 32 driver for the NXT to connect through. So you download that. We're going to put all the links for these up anyway, so don't panic. All the links will be there, and I'll put like a small step-by-step process on how to do it. Yeah, download that driver, go into your device manager, go update driver, and then click the LIB USB 32 driver. Now that driver will allow MATLAB to talk to the NXT brick. However, the NXT software that you get through Lego will not be able to talk to the brick anymore. Neither will that weirdly spelled and Next Explorer program. It won't talk to the brick either. Only MATLAB can. So once you've done that, go onto MATLAB, check out Liam's videos in week 2. He goes over how to communicate to the brick through MATLAB, how to set up handles, how to close the connections, how to open them, and he gets you to play a sound. If you get that sound playing and there's no warnings, no errors, then you're sweet. Everything's set up. This is just for the NXT brick. It's a little different for the EV3. I haven't set up an EV3, so if you guys could help each other with that, that would be cool. But yeah, any problems, throw them on the forum, and we should be able to work through them.
Now, Liam's included some code in, I think it's Revolute 2. Yeah, it's Revolute 2.
Where a basic connection to the NXT brick to play a sound. Now, if it comes up with an error, I think it's some settings, error cannot connect, blah, 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 you may still be running the Phantom driver. So if that's the case, go back and install the LIB32. The reason why you install the Phantom driver first is so the Next Explorer interfaces to the NXT bricks. So like when you're trying to load software onto the brick, you can't use the LIB32 or the LIB USB 32 driver because the external software it doesn't recognize the NXT. So yeah, I'll put it in a step-by-step process so it's easy to understand. And if anyone else has a better way, you know, comment it up because this did take me a while. Yeah, so that's that. Now, I mentioned Liam's videos. Liam has put up a set of videos. There's 6 sets, 1 for each week. Now, can we bring them up?
Yeah, let me bring this up for you. Nope. Okay.
Okay. Yeah. So on the left-hand side, you know, you've got your week 1. You got all the tabs that you want. Now, if you scroll down right to the bottom, you've got Project Build a Robot Arm. Now, in here is some useful information and some videos supplied by Liam. Now, this first one's the hardware. And then the second one, you've got this one Liam's just showing you 2 different types of robots working. It's not super informative, it's just cool to check out. Week 2. And then we got connecting to the NX2 brick. So this is what I ran. It didn't work for me first try. I ran into a few problems, and it was to do with had the wrong driver. In there is basically just make it beep. So it's a beep command, how to connect to it and how to use the handles and how to close connections to the brick. We got moving NXT motors. So the motors, it's a motor object. Now you can set different things in this object. You can set the power, you can set a brake. Liam will go through and show you how to do that, so there's no problem there. And then braking, obviously. We've got week 3. This one, Liam talks about how to build your robot. Now you got a choice between Revolute, or Revolute prismatic. I mean, maybe you want to go prismatic Revolute. I don't know. It's up to you. But it's really up to you. He talks about how to build a Revolute joint and how to build a prismatic joint. So you can go off and do whatever you want, but these are ones that will reliably work. So yeah, it's really up to you. And then you got key design decisions. So stuff to think about. You don't want the robot hitting itself when it operates. You know, you want to make sure it can reach all around its work area. Like you're given the A3 worksheet, you want to make sure it can reach right into the corners and then reach right up to next to the robot. And then yeah, connecting. You guys know how to play with Lego. And we got week 4. So again, this is moving your robot. This is again making sure it can reach all the sections and it spins and rotates the way you want it to. There's no clicking of gears or things falling off while it's working. And then the last section of that is measuring the joints. So you're going to need to know where your joints are, how long they are, so you can model them in MATLAB. This one's, yeah, developing your kinematic equations. This one I think everyone's going to have a lot of trouble with, solely for the fact that a lot can go wrong. You might put a cos in the wrong spot and the whole thing won't work. So if you have trouble with it, definitely post up your code. Also post up how you calculated your equations or what method you use behind it, so that we can go through and be like, oh, you missed that little bit there, therefore the whole thing isn't going to work. And then you got the last bit, yes, the same kinematics. And then you got week 6. This is Liam talks about the different joint movements. So you got joint movement and then you got Cartesian movement. It's really up to you which one you want to choose. Liam gives you advice on which one works better in different situations. And you're improving your performance. So yeah, when you set up your robot, you want to keep it simple, but you also want to make sure all the components are rigid. Now, I'll just show you my robot here. You got a little crushed in my bag, so it's not quite as good as I had it last night. But as you can see, there's a little bit of dip in this front bit. Now, that shouldn't be a problem because I'm going to have a pen at the end of this, and that'll hold it up. What will be a problem for you guys if you get the whole robot tilting when it's reaching right out far, and then when it's up close, if it's tilting back up, then you're gonna lose a lot of accuracy. So really make sure that you've thought out your design and it's relatively robust. Yeah, okay, so I'll just show you quickly mine working. I've basically programmed in a power of 20 to this top motor, so I'm saying move at 20% your speed, and then here on the bottom motor I'm saying again same thing, I've set it to 20% your speed, so this top joint should retract, and then this whole top piece should rotate around. Now the cables are a bit all over the place, you got to be careful. You should really tuck these in when you do your final final show or video. Now let me just run it. And at the end I've put the brakes on, so this is locked. I can't come in and spin this. The motors are preventing me from doing that. Now that's handy for when you're moving really quickly, because if your robot's spinning really quite fast and then your motor controller sets the speed to 0, the whole top could keep spinning a little bit, and you don't really want that, because that you'll lose accuracy. However, if you're using speeds like what I am of about 20%, then it may not be a problem. Like, you might not need to worry about putting brakes on there. It's really up to you. Just put a few commands in and see how well your robot works, whether it will need it or not, or whether you want to make the whole thing move faster or not. Yeah, that's about it.
Cool. Well, we had a couple of questions come in the last few days, so maybe I'll just shoot you some of those and see if we got some answers to these. First, we had what gear ratios do we use?
Yes, so that's really up to you. You want to keep your gear ratios relatively similar. You don't want this top piece spinning a heap and then this little piece in the middle moving like really slowly. You want them moving about the same speed, just so you get a smoother movement. But it shouldn't matter too much, because software side, you will be able to account for large gear ratios.
And then we also have, should I use Revolute or Prismatic?
Another one, up to you guys. Now, Revolute is the harder choice. Because you've got to calculate circles and the arcs that they move through. If it's the first time you've used MATLAB and you're still a bit iffy, go with a Revolute Prismatic. If you're a bit more advanced, challenge yourself, go for the Revolute.
Awesome. And we have a question came in from Renato Langerset. Apologies if I did not pronounce your name correctly. He was asking, can the flex of Lego's plastic parts be compensated by software control?
I'd say no, because the flex is non-linear. So you're going to get different flexes at different points or at different rotations, and maybe it'll flex differently if it's rotated this way. So realistically, you want to keep your flex to a minimum. If it's mine, it is a little bit, but I can say that's negligible. Like, it's going to draw reasonably accurately with, a tiny amount of flex. So, good question.
And we have Barry O'Donovan from Ireland. Hopefully he's sleeping right now, but he said he would tune in later and answer his question, can I define a limit on a Revolute joint rotation in a model?
Yes, you can. Yeah, that's not a problem. Barry, he also mentioned about...
He says he's a bit disadvantaged because he's running R2012A on an X26, so there's no Arduino support.
Yeah, and he wanted to
use
the MDL model.
Yes, you want to use the MDL planar 3.
Yeah, I'd really advise against modifying that. You can come up with your own code or come up with something external that calls, you know, the MDL model. Otherwise, yeah, you're going to run into all sorts of problems doing that, unless you're really, really advanced. But you know, yeah.
Cool. And lastly, we have one last question from John Davis, who says, do you know of any good Simulink examples or tutorials for a simple robot arm, especially for the EV3?
Off my head, no. If anyone does, please post a link up. If I come across any, I'll also post a link up somewhere on the forum, and I'll might hashtag you, or you know, it'll be somewhere there, and I'll make sure that you find it.
Great, great. And there was one other point I just wanted to point out about the peer assessment. Sorry, not the peer assessment, but when you submission would be through a YouTube video that you post the link to. We also asked if you could optionally submit a photo of your project in front of something cool. It'd be fantastic if you had the time to do that as well, and we might collect those and do a little mashup, something fun for the discussion forum. Okay, I think that's all we had today. Do you have anything else, Jack?
Well, just quickly, I'll just quickly show you guys. So this is my final year project. It's a mechanical hand that I'm designing to pick capsicum. Now it's based off the Open Yale hand, so Google Open Yale hand, and you'll know what I'm talking about. Even if you got a 3D printer, you could do this yourself mostly. Yeah, it's just if you like, you know, you really love robotics, yeah, definitely worth checking this out. I've modified this a fair bit to so it specifically works for picking capsicum, different joint sizes and the different stiffnesses. So basically, there's one motor at the bottom, and you've got 4 tendons, and they all pull in at the same time. And then, say this tendon hits my finger, this top piece. It's a bit stiff at the moment. I've got it's too stiff. I need to put too much force. But say this is a really heavy object that it's pushing, that tendon's going to come down and it's going to bend, and you can see, yeah, it'll bend and it'll get a good grasp on the object. But yeah, that's just something I've been doing, in case you guys were wondering. But yeah, it's something cool to check out, and a lot of you guys probably have 3D printers, so yeah, maybe have a shot at making one yourself. But yeah.
Great. All right.
That's it for today.
Yeah, thanks for tuning in, and we'll see you at the next event. All right.
See you guys.
Cheers.